Today we're throwing in compound probability. It's like multiple probabilities. It's like, what's the probability you're gonna flip a coin and get tails and then roll a 5 on a 6-sided die? So it's not too bad. You kind of just multiply the probabilities. So a compound event is 2 or more events occurring. Mutually exclusive means that they can't possibly happen at the same time. So I can't be in my classroom and also be in the cafeteria at the same time. Not possible. Oh, picking a king or a 4, right? You can't pull out a king that is also a 4. They're different cards. Now, you could pick out the probability of a heart or a king. That would be non-mutually exclusive. The formula is kind of, I think, overcomplicated. But if you see the word or, you're kind of like giving yourself a more likelihood that that would happen. So you're actually going to add those probabilities together. We'll get there. Let's do that. So we're thinking of a deck of cards. There are 52 cards in a deck. And there are 4 different suits. So there's 13 cards per suit. So we're looking for the probability we're going to get a king or a heart. So of the 52 cards, there's 13 hearts. There's 4 kings total. However, the king of hearts is kind of already handled in this 13. So there's only going to be 3 other kings. So there's going to be 16 favorable cards that we're looking for out of the 52. You always have to simplify it. 52 is divisible by 4. So if you divide each of these by 4, you'd have 4 over 13, and you can't simplify that anymore. The next one is almost identical, an ace or a spade. Because there are 13 spades, there are usually 4 aces total, but one of them is already handled in that 13. So there's only going to be 3 more. This is literally the exact same thing. 16 52ths, 4 13ths. Sick. All right. We want the probability we're going to get a 4 or a king. So how many 4s are in the deck? There are 4. Or it could be a king. How many kings are in the deck? 4. So if we add those up, we get 8 over 52. We could divide each of those by 4. That will give us 2 out of 13. That's cute. The probability it's going to be a heart or a face card. Of the 52, there are 13 hearts. Now usually, face cards, we could say, are jacks, kings, and queens because they have faces on them. So there's a jack, king, queen in the hearts. We wouldn't include that. But we have 3 of them in diamonds. We have 3 of them in clubs. Wow, that's an incredible club. And we also have 3 of them in spades. Artistically, this is just mind-blowing. So there are 9 face cards plus the other 13 that we're dealing with. So that would give us a total of 22 cards that we're looking for out of 52. Now 22 you can't divide by 4, but they're both even, so you could cut them in half. It'd be 11 over 26. All right, there's a couple for you to try. We're just going to do them right now. Queen or a spade. There's 13 spades. There are 3 other queens. This is the exact same as 1 and 2. It comes out to 16 over 52, which is 4/13. And a 7 or an ace, it's just going to be like example 3. There's 4 7s. There are 4 aces. 8 52nds. Comes out to 2/13. Great, fun. We're having a blast, folks. Independent events do not impact each other. So check out this first example. You have a bag of marbles. There's 3 red, 5 green, and 4 blue. We had that marble bag yesterday too. There are 12 marbles altogether. We want the probability we're going to draw 2 marbles with 1 red and the second blue without replacing the first marble. So our first draw is out of 12 marbles. We want to know what's the likelihood it's going to come out to a red. That would be 3 out of 12. We're going to multiply it by the second probability. Now it says without replacing the first. So once we take out a marble, we don't put it back. So there's not 12 marbles in the bag anymore because we have one. There's only going to be 11 left in there the second time. And out of those 11, how many of them are blue? Well, there were 4 blue. You could totally multiply across the top, across the bottom, and then simplify. I like simplifying before I multiply first. So like 3/12 would reduce to 1/4. You can even simplify diagonally as long as it's from one numerator and one denominator. So 4 goes into 4 once, 4 goes into 4 once. That's all we can do. Across the top, 1 times 1 is 1. Bottom, 1 times 11 is 11. That's the idea, folks. We're going to draw green the first time. So out of the 12, how many of them are green? 5. But this one says you do replace it. So you take one out, but you put it back in. So again, the second time we draw, there's still going to be 12 in there. Out of those 12, we want the second one to be red, which is 3. Simplify if you can. 3 goes into 12 4 times. Can't simplify the 5 with either of those, so we're ready to go. 5 times 1 is 5. 12 times 4 is 48. Yes! Here's a couple to try. We're just going to do them right now. You draw 2 marbles without replacing the first. So out of the 12, how many of them are blue? 4 of them were blue. But we're not putting it back in. We have a blue marble in our hand. So there's only 11 marbles in the bag. Also, there were 4 blues. I have 1 in my hand, so there are only 3 blues left inside the bag. Simplify 4/12 becomes 1/3, and then you can simplify the 3 with the 3. So again, we get 1/11. And red or green marbles. Both times, okay. It doesn't say if you put it back. Let's just assume that we're putting it back, I guess, since it doesn't say. So out of the 12, how many of them are red or green? Well, 3 plus 5 is 8. And we're saying we're putting it back in. So the second fraction is going to be the same. 8/12 times 8/12. You could divide these both by 4. That would give you 2/3 times 2/3, which would give us 4/9. Look at us, we're just having fun. I thought we were done. This is the last one. A teacher must select 2 students for a conference. The teacher randomly selects from 3 freshmen, 2 sophomores, 4 juniors, 4 seniors. What's the probability a junior and a senior are chosen? So let's see. There's 3 freshmen, 2 sophomores, so that's 5. 4 juniors, 9, 4 seniors. There are 13 students that they are choosing from. What's the probability that a junior and a senior are chosen? Well, how many of the 13 are juniors? 4. Now, the same student couldn't be selected twice, so the number we're drawing from the second time would be out of 12. How many of those 12 are a senior? Well, there were 4 seniors. We'll simplify. 4 goes into 12 3 times. That's all we can simplify. So 4 times 1 is 4. 13 times 3 is 39. This is it, folks. Don't get scared. If you're taking true-false tests, what's the probability you could guess correctly on 4 of those questions? Cool. So how many answer options are there for question 1? There's 2, right? The probability you're going to get that correct is 1 out of 2. Okay, there's our first answer. We have to do this for 4 questions. So each question we're going to have a 1 out of 2 chance of answering correctly. Here's our 4 questions. You can't simplify anything. Across the top we'll have 1. Across the bottom, 2 times 2 is 4, times 2 is 8, times 2 is 16. So you have a 1 out of 16 chance of guessing all 4 of those true-false questions correctly. Good luck with that.